All right, let's step up the pace a little bit and get into some more decorative or fancier types of cuts. Let's do some beveling, some corner rounding, and then we've got a special wrench that we need to make utilizing a form cutter. Going to be machining a block of 7075 T6 aluminum. We'll be using a 1/4 inch cornering rounding end mill and then a 90-degree form tool to go ahead and put a bevel or a chamfer all the way around the part. So let's go ahead and install our parallels in the vise. Remember, we want to keep those vise jaws clean. If we're going to be using a particular setup again and again, be sure and spray a little WD-40 or spray oil against the parallel and the vise jaw so those two stick together and we don't have to constantly be cleaning the chips out from behind the parallels. Mount our block, push down with our left hand as we secure the vise and then loosen it, making sure that everything stays tight and it doesn't shift during that tightening operation. Choose a corner rounding end mill first. It's a 4-flute design. It's going to put a very nice decorative rounded edge around our part. If we're doing some custom tooling, building some parts for somebody's race car, having nice round flowing edges is really important in that finished job. All right, we can see now as we'll rotate the cutter, our actual cutting edge is right here. You can see the lower part of the cutter. So what we're going to do is rotate that around and bring that in contact with the top of our workpiece by using the quill, locking the quill down, and then we're going to lower the table 5 thousandths. And this will establish the correct cutter height. Not the depth, but the cutter height. Okay? So we'll rotate it around. We'll just come in contact, lock our quill down, go down to the knee, drop it 5 thousandths, lock the knee in place. Now our next critical dimension is going to be the amount of cutter that we feed into the workpiece. We don't want to cut a groove along the bottom of it. We just want a full radius that we machine around that edge. So it's going to require some careful checking on our part as we feed the cutter in order to make a perfect radiused edge. We'll back the cutter away from the part, don our safety glasses. We'll turn the end mill at about 1100 RPM. So we're using aluminum. We can grab our can of WD-40. Okay, we'll conventional mill initially, and watch closely now as we bring the cutter into contact with the workpiece. Okay, we're going to look on the inside of the cutter and watch the cutter as it comes up against this vertical side. You'll see the radius starting to form at that point. Okay, we'll just give it another 2 or 3 thou on a climb cut for a finish pass, and we're going to come back across the part. Make sure and lock your gibs down on your final pass. Nice, smooth, even rotation of the hand wheel on our y-axis. All right, let's get our cutter out of the way. Take a look. Okay, we've machined a real nice rounded radius over the top of the part. We don't have any heavy line where we've cut it too deep. That setting is just perfect, and that really dresses up the finished part or the piece of tooling that we may be working on. Now I'm going to run the cutter around on the back side do the same thing, and then we'll come across on these outer edges and produce a 45-degree chamfer along those, showing you two different styles of beveling the edge of our part. All right, here we go on a final pass. Now let's go ahead and switch cutters. Okay, we'll start on the front side now, providing you a little better view of what we're doing. The height adjustment, since we're cutting on a long 45-degree surface now, isn't really critical as long as we extend the point below the width of the cut. Okay, and what we're going to do, you can see on this rounded edge, we're going to want to cut our 45-degree chamfer right down to the bottom radius, or bottom edge of the radius, where it comes into the straight section on the side of our block. Okay, and again, we're going to turn the cutter at same RPM, around 1100. Okay, take a light pass initially. We're cutting in a climb mode right now. We're just about to full depth. Okay, we'll view the end of our part, and let's take about another 5 thousandths. Lock our table down, come back and climb cut for a final pass. Going to produce a very decorative looking part, whether it's a tooling fixture, an instrument panel. Always take pride in the finished job. If you exhibit a little more creative talent than the machine shop down the block, I can guarantee you you're going to be busy with lots of work. If you turn out shoddy workmanship, no creative or decorative thought in mind, they're going to move on to the next guy who is a little more artistic in his machining techniques and capabilities. Okay, we're ready for final pass now. We'll pull the part out for inspection. We're using a feed rate of about 8 inches a minute. All right, let's take a look at what we've got. All right, there we have our finished block. You can see our 45-degree bevel along the side, nice and smooth, flows evenly into our 1/4-inch radius corners on the sides. So it makes a really good looking part. If we were to set that down and put a dial indicator on it, a couple of dowel pins, a hold down clamp somewhere, we'd have a real nice base for a piece of tooling that anybody can be proud of. Remember to have a little finesse in your work. We want to turn out something that looks good as well as functions for the intended task. Now let's take a look at another way to apply a bevel using a V-block. All right, if you don't have a form cutter, yet you still want to cut a nice beveled edge on the part, what do? Rather than tilt the head and go through the hassles and pains of retramming the head back in, simply insert your work in a V-block. Use a penny or something to insulate the work between your hold down clamp. Hold it in place, and we can use a conventional end mill to come in and cut a bevel all the way around that part. Bear with me while I change cutters. I'll be right with you. Again, don't be afraid to just grab some material. If you see it on sale somewhere at your local metal shop or steel supply house, and they've got a load of aluminum or steel that's around there that you can buy for a bargain, cash in 10, 15, 20 bucks worth. Take it home, practice, build yourself some tooling fixtures, get familiar with the machine, get familiar with the different cutting operations, so when it comes time to perform a job, it just becomes second nature and you can snap your fingers and the parts just pour from the machine. Okay, we've got our part set up. We're going to bring our cutter down, just come in contact with the work, lock our quill down. We're going to raise the knee 10, 15 thousandths, and watch now as we again put the same type of a bevel or chamfer on our top edge of our part. Do these in series for the different widths and dimensions that you have. Remember to keep track of how many thousandths you feed the cutter into the workpiece so you can duplicate that on all the other existing edges simply by rotating the part in the V-block. Have a nice smooth feed rate as we cleave off that little chamfer across the top of the part. Okay, we've got a real nice bevel on that side. Simply reverse the part. Keep our cutter setting the same. Wipe out our V-block because we've got some chips and stuff to contend with. If you get a chip underneath it, you're not going to have a uniform chamfer around your part. Always take our hand, wipe it across the part. We can feel really well. Don't take for granted that simply one pass of the towel or shop cloth got all of the chips out of the way. Hold our part down into the V-block, tighten our clamp, and with the cutter on the same setting, we're just going to proceed to come across the top of the part, putting an absolutely identical chamfer on the opposite side. Now, let's take a minute and install a form tool, and I'll show you how to build a special wrench, or at least one that I manufacture for different companies around the country. All right, we've machined up a blank for the particular wrench again that we manufacture. This wrench is for the ever popular Remington 700. We sell these to gunsmiths and Remington owners all across the country. You can see the formed profile that we're going to be machining. The most efficient way to do that is with a form cutter. So let's go ahead and install our blank in the vise, clamp it down, and I'll show you how to properly set the height for the form cutter. Set it up on a parallel, an adequate amount exposed. We want to keep a nice rigid setup now. Tighten our vise down. This is a sample of our form cutter. We showed you this before when we made a sample cut on a piece of aluminum. We have a radius ground in here that matches the profile of the body of our wrench. Then these flats are going to come in and cut the rails, if you will, on the wrench. So we've got it installed in our AccuPro tool holder, good rigid setup. Let's install it in the mill. Remember, we talked earlier when you have form cutters done that you want to establish from the bottom of the cutter to the center of the radius. And this is done on an optical comparator for whomever is grinding your form tools for you. Then they're simply going to inscribe along the cutter what that dimension is. This particular one is 792 thousandths. So once we come in contact with the top of the part, we simply raise the bed or lower the quill 792 thousandths in order to center this radius on our workpiece. I'm going to bring the cutter over the top of the part, lower the quill until we just spot on the cutter, lower the bed 5 thousandths, move our cutter off. We're going to turn the machine on now. We're going to run this part at around 325 RPM. We're machining a piece of heat-treated steel. Shift your machine into back gear, lock the quill down. Index our part over the top, slowly raise until we just spot on top of our part. Loosen the lock ring on the knee, set our dial at 0, and then proceed to raise the bed half of the diameter of our part. Got a 1-inch piece of material here, so we're going to go a 1/2 inch plus 792 thousandths, okay? And that'll put us on the center of the part. Okay, we made those adjustments on the Z-axis. Okay, we're just going to come in now in a conventional milling direction. Come in contact with the work. Back away from it. We're going to apply a little bit of cutting fluid. We'll use a good sulfur-based oil. Okay, are you listening to the cutter? What you're doing is making little chirping sounds, isn't it? We're also getting a little bit of clunking out of it. What is that telling us? You're probably running the cutter a little too slow. All right, so after we make this pass, let's go back and change speeds, and you let me know if it doesn't sound like a more appropriate speed for this particular cutter. Okay, we're going to shift gears. Let's try 660 RPM. See what that sounds like. Okay, we're still getting a little bit of noise. Increase our feed rate a little bit. Come across it with a climb cut. Okay, what are your thoughts? We've shown you 2 speeds, 2 feeds. Which would you prefer? All right, we've got 2 ways to go. We can lighten the cut up a little bit, continue at 600 RPM, taking a little bit heavier cut. The machine is talking to us again. We'll watch in a climb cutting mode if we take, again, just a little bit of a lighter cut. Not a lot to suck the cutter along. But we machine pretty smooth under those conditions, but we're still getting a lot of chatter out of the part. So probably we're better off opting for that speed of 325, slowing our feed rate down just a little bit. So you can see how to fine-tune the cutting operation based on what the machine is telling us by the chatter, by the vibration and noise. So we'll just take our time, we'll putt along here in back gear, adjust our feed rate accordingly. Remember, we've got a lot of material exposed from the vise. It's trying to spring away from the cutter. Keep plenty of fluid on the cutter as we're machining. All right, we've given you different examples of the form cutters. I'm going to go ahead and finish up on the back side. I'll join you in just a minute with the finished product for final review. Okay, you can see the profile, the radius top edge here matching the diameter of the part that we have. So that's an example of what a form cutter can do. If you've got some specialty operations that are difficult to machine in other axes, spend a few extra bucks, have some form cutters done, make the necessary tooling to hold your parts and pieces, and you'll come out with a dynamite looking job when you're done. All right, that's pretty well a wrap on rounding corners, using form tools, using a V-block to cut a bevel or a chamfer on something. Let's continue.